Have you ever wondered why some relations are called functions while others are not? Most students simply memorize the definitions, but mathematics becomes much easier when you understand the ideas behind them. In this video, we'll build the entire chapter from scratch. By the end of this lesson, you'll clearly understand ordered pairs, Cartesian products, relations, domain, codomain, and range. Now let's begin with the most basic building block of everything that comes next: the ordered pair. Imagine one set contains students, and another set contains their roll numbers. Now consider the ordered pair Rahul and 15. It simply means Rahul has roll number 15. Now let's reverse the order: 15 and Rahul. Does it represent the same information? Not at all. A roll number doesn't have a student. Instead, a student has a roll number. The same two objects are present, only the order has changed, yet the meaning changes completely. That is why they are called ordered pairs. In mathematics, order always matters. Now that ordered pairs are clear, let's move to the next important idea: the Cartesian product. Imagine a cafe. Suppose set A contains two drinks, tea and coffee. Set B contains two cup sizes, small and large. Now imagine every drink is available in every cup size. So we get tea in a small cup, tea in a large cup, coffee in a small cup, and coffee in a large cup. Every drink is paired with every size. Nothing is skipped. This complete collection of all possible ordered pairs is called the Cartesian product. Now we are ready to understand relations. A relation is simply a subset of the Cartesian product. That means we first create every possible ordered pair. Then we choose only those pairs that satisfy a particular rule. Suppose set A contains the numbers 1, 2, 3, and 4, and set B contains the numbers 2, 4, 6, and 8. The Cartesian product contains every possible ordered pair formed from these two sets. Now suppose our rule says that the second number must be twice the first number. Immediately, most ordered pairs are rejected. Only the pairs 1, 2, 2, 4, 3, 6, and 4, 8 satisfy the condition. These selected ordered pairs together form the relation. So always remember this: every relation comes from the Cartesian product, but a relation usually contains only those ordered pairs that satisfy a given rule. Now let's understand three terms that students often confuse: domain, codomain, and range. Don't worry, they're much easier than they sound. Imagine 4 students have registered for a sports competition: Rahul, Priya, Aman, and Neha. The available sports are football, cricket, chess, and basketball. Now suppose Rahul chooses football, Priya chooses cricket, and Aman chooses chess. Neha doesn't register for any sport. In this situation, the domain consists of Rahul, Priya, and Aman, because these are the students who actually have a connection. Notice that Neha belongs to the original set, but is not part of the domain because she is not connected to any sport. The codomain is the complete list of available sports: football, cricket, chess, and basketball. Finally, the range contains only those sports that were actually chosen: football, cricket, and chess. Notice that basketball belongs to the codomain, but it is not part of the range because nobody selected it. Now let's see how relations can be represented. The first method is called the roster form. Here we simply write down all the ordered pairs. The second method is the arrow diagram. We place one set on the left, the other set on the right, then draw arrows showing the connections. The third method is the graphical representation. Here, every ordered pair is plotted on the coordinate plane. Although these three methods look completely different, they all represent exactly the same relation. Congratulations! You've now learned the basic language of this chapter. You understand ordered pairs, Cartesian products, relations, domain, codomain, range, and the different ways to represent a relation. But here's an interesting question: is every relation a function? Most students immediately answer yes, but that's actually not true. In the next video, we'll discover what makes a function different from an ordinary relation. So if this explanation helped you, don't forget to like the video, subscribe to the channel, and I'll see you in the next lesson.